Hello grade 11s. So we're starting 7.1 and we're going to merge that with 7.2. This unit 7, is all about quadratic equations. Now, as we've talked about in class, quadratic equations are equations that have a variable to the power of 2. This makes them quadratic. Okay? And quadratic equations will always form a parabola when they are graphed. A parabola that opens up like this, or a parabola that goes down like this. And we can think of many real-world parabolas. This happens in nature all the time. If you think of a ball being kicked, it goes up in that curve and then comes down. If you think of water spraying out of a garden hose, if you think of someone standing on a bridge and tossing a rock as high as they can, and then the curve of it makes when it comes down. Okay, parabolas. We also see parabolas in arches in bridges, in homes, etc. Okay, those are quadratics. So a quadratic equation is always going to be in this standard form. And we have looked at this, even as we've been factoring, we've talked about ax squared plus bx plus c. Now, we haven't put it in equation form until now. Equation form simply means that there's an equal sign. And standard form has it equaling to 0. If we look below, a and b and c are known values where a cannot be 0. Obviously, if a was 0, 0 times x squared, this would not be a quadratic anymore. X is the variable or the unknown. We don't know it yet, obviously. So when we're asked at the bottom here to find a, b, and c values of the quadratic equations before, the first one we can look at and know. A is in front of the x squared, b is in front of the x, and c is the constant term at the end, and the whole thing equals 0. The next one, okay, this one looks a little different, doesn't it? What's happening here, if we would rewrite it in the form that we're looking at, plus c, there is no c, so it's 0. So in this case, we could say a equals 1, b equals -3, don't forget the negative, and c in this case is 0. The last one, well, I look at it and there's no variable squared. This is not a quadratic equation. If I scroll down just a little bit further on your page, here we've also got, they're quadratic equations because this first one anyways has a w squared, obviously, but it does not in standard form. It is not easy to see the a, the b, and the c. So this requires a little bit of math work before you can identify the a, the b, and the c. Here we see we need to distribute the 2 throughout. So we're going to get 2 times w squared minus 2 times -2 would be a -4w equals 5. Now, it's getting closer, although we see standard form must be equal to 0. So we need to move this 5. This needs to be 0 on the right side of the equation. We need to move the 5 to the other side. Or we need to do something to make this 0 on the right. And what we need to do is subtract 5. We know we can't just randomly subtract 5 from one side. What we do to one side, we have to do to the other, so the whole equation stays equal. Now we can rewrite it. We've got 2w squared minus 4w minus 5. Now I can't subtract this 4 from the 5. This is 4 w's. Okay, we don't know what w is, so we're not quite sure this value. We have to just leave it as -4 w's. -5 is a constant term. It cannot be grouped with w's. And on the right side, 5 minus 5 equals 0. Now we can see that. without too much difficulty, we can see that A equals 2, B equals -4, and C equals -5. Excellent. Lastly, we've got a question here. Now I can see if I distribute the z, I'm going to have a z squared. So yes, this is a quadratic equation. Let's do that. We're going to get z times z is z squared. Z times -1 is -z equals 3. Again, we cannot have it equaling to 3. In standard form, it always equals 0. So we need to make 0 on the right side, and what we do to one side, we have to do to the other. So then we've got now z squared, subtract z, subtract 3. Again, this 3 cannot be grouped with the z's. They're two different terms. 3 minus 3, 0. Now we can identify A equals, 1, B equals, in front of the z, -1, C equals -3. Excellent. Turn the page. So we're calling the shape of a quadratic equation a parabola. I would like you to follow this link, if possible, and experiment with the effects of the A, the B, and the C. Remember, standard form is this: ax squared plus bx plus c equals 0. So what happens, and this link will help you to find this out, what happens when the A changes from positive to negative, or something huge to something little? What happens with the different numbers for B? And what happens to C? And then we'll fill in this rest of this together. Okay, I changed my mind and thought I'd just explore it with you. So here's A value. If you grab this and, pull it up and down, the value for A, look what happens. Okay, right now A is negative, and then A, right at 0. If A is 0, it's not a quadratic equation anymore, remember? Because there's no squared. I can't make it 0. It would be a flat line if it was 0. And then look when there's negative A and then bam, positive. Can you see what the A did in that case? I'll move it down. Okay, so the A, if the A is positive, it opens up. If the A is negative, the parabola opens down. Okay, let's look at the other numbers now. When I move B from 0 up, what's happening here? Basically, B moves it from side to side. And C, what happens here? Right now C is -1.6. Let me put C down to -0.5. You see it? I put C up to 0. What's happening here? How is the parabola affected? Now C is at +5. You can see that with the value of C determines where it crosses that red axis, or the y-axis. Okay, let's go back to our notes and let's write these things down. So if A is positive, then the parabola opens up like that. Like this. And we say that that parabola has a minimum value, meaning it has a spot where it gets the lowest. If A is negative, then the parabola opens down like this. And we say that that parabola has a maximum value, or it has one spot where it reaches its highest point. Okay, now B. In general, we're not going to get too detailed into the B, but it moves the graph from side to side. And C, we knew that C is the y-intercept, or the place where that parabola crosses the y-axis. C then moves the parabola up and down, moves the graph, or we can say parabola up and down. Okay, let's go down and we're going to draw a detailed sketch now of a parabola. I'm going to draw it first and then we'll explain it. Okay, so go ahead and pause the video now, and I'd like you to draw the black parabola onto your notes. Once that's done, you can start the video and stop it whenever you want to write in the things as we discuss them. So, first of all, let's start down here at the vertex. The vertex is this point that's the bottom of the parabola, or if the parabola is opening downward, then this vertex would be at the top. The vertex is an ordered pair, an x, comma, y, so that refers to the 2 on the x-axis, and this is the x-axis, and a -7 on the y-axis. The vertex, this one anyway, is the parabola's minimum value. It is the lowest spot that the parabola goes. Okay, we also know that this parabola opens upward. We can see that just from looking at it. The mouth of it, the parabola is facing up. Therefore, we know that the a value of its equation must be a positive value. Another word for opening up is concave up. All right. The line that runs straight down the whole center of the parabola is called the axis of symmetry. Symmetry because this line divides it exactly in half, meaning it's symmetrical on either side of this line. In this case, we say that the equation of the axis of symmetry is x equals 2, because that's what this line is, everywhere where x equals 2. The interesting thing, which may be obvious, is that the axis of symmetry then divides the parabola exactly in half. So if you don't know where the axis of symmetry is, you could always look and count the number of graph pieces or the number of lines across the parabola and then divide it in half. And you could find the axis of symmetry. All right, another point with this parabola is the y-intercept. So you can see here is where the parabola intercepts or crosses over the y-axis. This is y equals 1, 2, 3, 4, 5, -6. And then in the equation to this parabola, we would know that the c value is -6. Another interesting thing to note about the y-intercept is at this spot, the x value is always 0. So if I would want to write the ordered pair of that spot, I would have 0 for the x and a -6 for the y. Okay, let's look over here at the x-intercepts. So the y-intercept is where it crosses the y-axis. The x-intercept will be where it crosses the x-axis. Okay, and in this case, there's 2 spots. If we would move this parabola up, 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 there could be a chance of having only one x-intercept if the vertex was right on the x-axis. If we move it up even further, there is a chance of having no x-intercepts if it doesn't cross it at all. Another thing to note is that x-intercepts have a lot of different names. We call them zeros, we call them roots, we call them the places where y equals 0, we can also call them solutions, etc. We'll explore that a little bit later. Okay, so moving down here, I want you to answer 2 things about this question. Looking at this quadratic equation right here, if I would write it in standard form, I would say 0 equals 2x squared plus 8x plus 8. I would like the y-intercept and the concavity. Pause it and look up if you don't know at the graph. Okay, so the y-intercept comes from the c value. It's 8. Here's its ordered pair. The a tells you the concavity, which is up.